Good afternoon. My name is Mohammed Abu Jafar, and today I'm presenting my retail analytics project titled From Data to Insights. I analyzed 263,000 transactions from multi-channel retail company to solve critical business problems. I implemented 13 analytical tasks across four components, which is recommender systems, pattern mining, forecasting, and fraud detection. Although this is just an assignment, but I have tried to build a production-ready infrastructure with measurable business impact. I'll show you now the problem we are solving. Now, the business context is that I'm working with a multi-channel retail company, similar in scale to Amazon or Walmart, maybe. They have 5,000 customers, making hundreds of thousands purchases over 2 years across five stores, both physical and online. They sell around 500 different products across six major categories, which is electronics, home, beauty, sport, grocery, and clothing. Now, the company faces three critical business problems, which is first, the loss revenue through generic recommendations, fraud losses from reactive detections, and customer churn with no early warnings. On the first problem, the company treats every customer identically, whether you're shopping downtown on a Monday morning, maybe at 8 a.m., or browsing online Saturday night at 11 p.m., relaxing at home. You get the same exact product recommendation. So, this one size fit all approach completely ignores the shopping context. The second problem is the fraud losses through reactive detection, is that their detection system, the fraud detection system, is a bit reactive. It catches only obvious fraud cases. Sophisticated fraud patterns are stepped through undetected, of course. So I estimated losing around 300,000 or more annually to fraud that could have been prevented. They have no proactive protective system to catch suspicious transactions before the money is lost. The third problem is the company has a zero warning system for customers who are about to stop shopping with them. High value customers start leaving silently, and by the time the company realizes has churned, it's too late to intervene. That's millions of dollars in a lifetime value walking out of the door. So my solution is to build a data-driven system that solves all three problems with a quantifiable business impact. My success matrix is to ensure that the revenue is increased through a context-aware personalization and reduce the fraud losses through machine learning-based detection and prevent the customer churn through a predictive early intervention. And of course, deliver a measurable ROI. I'm targeting 1.5 million to 2.3 million in annual business impacts. Now, sorry. Now, on the technical solution, I have four components. The recommender systems, I've implemented four tasks. I've used collaborative filtering, matrix factorization within MF, and association rule mining with a priori. I build a context-aware recommendation, product bundles, loyalty targeting, and brand affinity recommendations. The key technical innovation here is the per context normalization. With this normalization, I compute popularity separately for each time location combinations. This ensures each context gets products that are actually relevant to that specific shopping situation. This single decision improved the recommendation system significantly, and it started, differentiating between generic recommendation and personalized recommendation. The second component where I have implemented the three tasks is the pattern mining. I used some statistical methods, specifically square test for independence to discover weekend versus weekday shopping patterns, seasonal trends, and complementary product associations. The third component where I've implemented the three tasks is forecasting for revenue forecasting. I shows exponential. I always struggle with this word, smoothing for churn prediction and return rate forecasting. I used random forest as well. These methods naturally handles the trend and seasonality, which is exactly what revenue exhibits. My implementation achieved a good result, which is similar to the industry standard. Random forest for churn and returns because these depends on complex nonlinear relationships between multiple features. So random forest handles feature interactions naturally without requiring me to specify them. The last component is fraud detection, where I implemented three tasks. I took a multi-method approach, Z-score, IQR, and plus a gradient boostings for supervised machine learning. Uh, Fraud is diverse, so that's actually the reason statistical methods catch transactions that deviate from the normal patterns. Machine learning catches subtle combinations of features that individually look normal but together signal fraud. This layered defense is, as per my research, is one of the best practices in the industry for fraud detection systems. So this made my life easier because I used to keep a lot of notes here on how to do things in a standard way from a project to project. And I will just start by opening a terminal, and I will show the just test I made. List in, or my just file. Uh, these like as I understood in class, it's more of about reproducibility, simplicity, and of course the product production readiness. So now the context-aware combination component. Sorry, here I will see correct working directory, setups the Python environment properly, loads my sources and modules, and run the context-aware recommender with all correct parameters. It's just all in one command. Now here I have 4,600, sorry, 4006 recommendation across generated across 821 unique shopping contexts. This is the automatic summary output that is built into the script for immediate feedback. Now I can also show you the generated outputs. The ETA analyzed the 263 transactions and discovered these 12 patterns. Electronics, for example, dominates revenue, and most shopping happen in physical stores, and peak hours are usually 2 p.m. Now, baseline. I tested three baseline recommendation methods. Item-based collaborative filtering performed best, and this became our benchmark to beat. Now here in the folder, I can show my, yeah. So these are the 13 implemented tasks, context-aware recommendation for 821 shopping situations, fraud detections with 95% plus probability scores and suspicious transactions, and revenue forecasting with 18.8 error rate. Now, I can also now go and run the fraud detection. So I can say using the just library is just run fraud supervised. Yeah, so this takes a bit longer because it's doing real machine learning computation. Here, if we go to the about supervised. Yeah, so here it's defining them by the risk type, the method of payment, and I want to see low risk. You notice here low risk is a card install payment, where, for example, a crypto should be high risk. It's based on the probability, the predictive floor, the risk level, and the total amount. So it's not just one component. Now, this is now the automation I've tried to do is a single command, which is just run all tasks. It executes 13 analytical tasks across 4 components, which is the recommender system, pattern mining, forecasting, and fraud detections, the entire pipeline. So this one command, complete analytics system, 17 CSV outputs, and that is the production grade data science infrastructure I was trying to achieve. This will definitely take some time. So I can go back to the slide a little bit. The business impact and trying to translate these technical results into a business value. This is where the data science becomes the business impact. So my analysis discovered around 800 unique shopping contexts, every combination of the week, hour, and store location, and purchasing patterns that is vary dramatically across these contexts. So the business action is we would implement a time-based product displays on the e-commerce website and a dynamic in-store signage, maybe show a breakfast item and a coffee in the morning, where we will have in the evening dinner ingredients or maybe wine, and the weekend home projects bundle, of course, on a Saturday. So the expected income is 500 to 750 additional revenue. The second insight is the heading high value customers who are waiting to be converted. I discovered that 2,000 non-loyalty members who already shop exactly like our best loyalty members, high purchase frequency, high average basket value, and other components. So the business action for them would be to launch a targeted loyalty enrollment campaign focused on the top 200 highest potential uh, prospects, I would say, personalized, maybe with maybe a personalized email with customized product recommendation and a special enrollment incentives. So the business impact or the expected impact would be around 15 to 20 conversion rates. Those estimates for like around 30 loyalty members, and historical data shows that each loyalty member worth around 1,000 to 1,500 more annually than non-members. That is around half a million incremental first year value, and these customers stay loyal for years. The third insight is the fraud that has a learnable, I would say, pattern despite of the class imbalance. So even with 98 legitimate and only 2% fraud transactions, the model identified a clear fraud signals. Feature importance analysis reveals these patterns. So uh, I don't want to be repetitive. I explained most of that earlier, but the business action would be deploying the model in production with two-tier review process. The high risk transactions that gets immediate manual review before approval, and medium risk that get post-transaction monitoring, and low risk that auto approves. The expected impact is 300,000 on fraud prevention annually and 60 to 70% in fraud losses. Critically, catching a fraud before money leaves the system, not trying to recover it afterwards. The Fourth insight is the predictive analytics that enables proactive decisions. Customer churn is predictable 60 days in advance. Product returns are forecastable before the inventory is restocked, and revenue projectable 30 days out with industry-leading accuracy. The business action would be building an automated alert systems with customer hits churn risk threshold maybe, notify account manager, and when the product return rate exceed the targets, we can alert the procurement, or when revenue forecast changes significantly, maybe update the inventory plans. The expected impact is 200 to $400,000 in return revenue through early intervention and on churn and returns. The total business impact overall is 1.5 million to 2.3 million. That is combined in an annual impact, and that is like 15 to 10 to 15 times the return on investment in data analytics infrastructure. Now, these are not just insight, these are actionable recommendations with a quantified financial impacts, a clear implementation path, and realistic timelines. Now, on the technical side and the self-assessment I've done, I would say that this project is everything in this project is reproducible. I used UV with Python 3.13 for exact environment replications. I fixed random seeds at 42 throughout every script. Anyone can run one command, which is just run all tasks and get identical results down to the decimal points. The UV log files locks every dependency version, ensuring no drift. Now, honest assessments on the limitation, I want to be transparent about the weaknesses as I still even try to fully understand the code. I understand the business context and I understand how these techniques helps the business. And I think I'm missing some of the puzzles maybe in the big picture. But I feel as I do this demo, I keep learning, and I really like the materials that you have provided because they were very insightful and helped me with the learning process. So I appreciate that. Now, the limitation one is the cold start for a new customer, and the new customers, of course, will not have purchase history. So my mitigation was to implement a popularity-based fallback. A new customer gets recommendation based on what is popular in their context until we collect like 3, 5 transactions. Then we gradually transition to personalized recommendation. Limitation two is the fraud detection. Uh, I know that 2% fraud creates severe scoring challenges. This is why the AUC is 0.55, not 0.95. My limitation was the multi-method approach combining statistical outlier detection with machine learning, threshold tuning to optimize precision recall trade-offs for business needs, manual review process for high-risk transactions so human can make final decisions, and honest metric reporting with full context, not hiding the challenge. The third limitation is the historical data span. It's just 2 years historical data. Seasonal patterns would be significantly more robust with 3 to 5 years of data. Uh, so it's merely a constraint, not a methodology issue. So the future work would be about maybe having or redoing this exercise with additional historical data for a similar company. So these models and methods are ready to handle longer time series. The limitation four is the model drift over time, which is the customer, because the customer behavior changes like all human does, seasonal shifts, new product launches, competitive dynamics, model trained on past data gradually become less accurate. So my mitigation plan was a quarterly returning schedule built into deployment plan, performance monitoring dashboard to detect drift early, and automated alerts when key metrics degrade. it's an ongoing maintenance. That's on the summary. I would say this is the achievements or the project achievements actually, which I've said like later on. Sorry, before I mean. The implementation roadmap as requested is around 3 months, and I would say we would deploy the fraud model test and monitoring in the first 2 weeks, then maybe the loyalty campaign and the third and fourth weeks. Maybe by the second month, we will have some test on the context aware recommendation. And by the third month, we will have the full production rollout across all components.